All right, let's get right into it. Think about the companies that build the most complex, most important machines on the planet, the ones that literally print the technology that runs our world. For them, 2025 was no ordinary year. No, it was a crucible, a year of unbelievable pressure from all sides that pushed them to the brink and completely changed the game. So that really boils down to one huge question. For these companies, was 2025 an absolute gold rush, a chance to make incredible profits from a historic tech boom? Or was it a minefield, packed with geopolitical traps that could blow up at any moment? And here's the wild part. The answer is yes. It was both, happening at the exact same time. So let's start with that idea. Section 1, a year of extremes. For the big names in chip equipment, we're talking ASML, Applied Materials, Lam Research, and Tokyo Electron. 2025 was basically a giant tug of war. Two incredibly powerful, opposing forces were pulling them in completely opposite directions. And this really shows you that paradox perfectly. On one side, you have the AI gold rush, just this bottomless pit of demand for more computing power, kicking off a massive supercycle for the most advanced gear. But on the other side, you've got the geopolitical minefield. Tech wars heating up, new export bans popping up, basically walling off massive markets and creating total chaos. It's like trying to drive a race car with one foot flooring the gas and the other slamming on the brakes. That was their reality in 2025. So let's zoom in on that accelerator pedal for a minute. Section 2, the all-consuming AI engine. You see, this wasn't just another product cycle. The demand from AI was a full-blown tsunami that was reshaping the entire industry. You know how everyone and their grandma is talking about AI? Well, all that AI needs an absolutely insane amount of specialized hardware to run. So companies like NVIDIA were just desperate for more chips. And that desperation flowed right down the food chain to the guys who build the machines that make the chips. The whole system was running red hot. And get this, we're talking about high bandwidth memory, HBM. Think of it as the ultra-premium rocket fuel for AI chips. Well, before 2025 even properly began, one of the biggest players, SK Hynix, had already sold its entire production capacity for the whole year. That kind of demand is just bonkers. And where there's that much demand, big money follows. Micron dropped a cool $7 billion on a new factory just to make more of this stuff. When you see checks that big being written, you know this isn't just hype. It's a fundamental revolution in the market. So what this all meant was that chipmakers suddenly had a very specific and very expensive shopping list. They needed the latest EUV lithography machines from ASML to draw circuits smaller than a virus. They needed special bonders to stack those HBM chips like tiny, powerful skyscrapers. They needed new packaging tools to cram all this stuff together. And crucially, they needed amazing new inspection tools from companies like Kayla to make sure it all actually worked. This was the gold rush. But just as they were cashing in on this gold rush, they had to step very, very carefully through that minefield we talked about. So, Section 3, navigating the geopolitical gauntlet. And trust me, the ground was shifting under their feet every single day. The biggest issue, of course, was the escalating tech war. The US kept tightening the screws, putting more restrictions on selling the most advanced chipmaking equipment to China. For decades, China had been a huge growth market for these Western companies. And now suddenly, that giant market was being walled off. And this wasn't just some abstract political problem. It had real immediate costs. Look at this. Applied Materials projected a $400 million revenue hit. And get this. That wasn't from lost sales of new machines. That was just from being told they couldn't service the equipment they had already sold in China. That sent a shockwave through the entire industry. So, what do you think happened next? Did China just give up? Of course not. If you can't buy the best tools from abroad, you have to build them yourself. And you have to do it fast. The export controls basically lit a 5-alarm fire under China's domestic industry to become self-sufficient. And the results were almost immediate. Check out these growth numbers for Chinese equipment makers like AMEC and Naura. Their sales just exploded. Because Chinese chipmakers were forced to buy local, it created a massive boom. The US had, in effect, created a whole new set of heavily funded competitors on the world stage. And China was backing this push with an unbelievable amount of cash. The so-called Big Fund 3 was a $47 billion war chest. Let that sink in. $47 billion, all aimed at building up their own domestic semiconductor industry. That's the scale of the new competition. Okay, so you've got the AI gold rush pulling you forward, and the geopolitical minefield trying to drag you back. As if that wasn't enough, there was a third major battle going on, a battle against the laws of physics itself. Welcome to Section 4, Racing to the Angstrom Era. Now, the hero of this story is a piece of tech called high-N EUV lithography. It's basically the next generation pen for drawing the circuits on a chip. It uses a super focused beam of light to draw features so small they're measured in single-digit numbers of atoms. This is the tech that gets us to future chip nodes. But here's the catch. This incredible new machine, which only one company on Earth, ASML, can build, costs around $400 million for one machine. And that creates a huge dilemma. Is this leap in technology actually worth a price tag that rivals a small country's GDP? And that brings us to what the industry calls the high NAS gamble. You've got Intel on one side saying, look, the machine's expensive, but it simplifies the process so much that it actually saves us money in the long run. But on the other side, you have the industry's backup plan. Stick with the older, cheaper tools and just use more complicated tricks to get the same result. It's a massive, multi-billion-dollar bet on the future of manufacturing. And this quote from Larry Melvin at Synopsys absolutely nails it. The conversation isn't about physics anymore. We know the tech works. The real question is about economics. The price of admission is getting so high that maybe only 2 or 3 companies in the entire world can afford to play at the cutting edge. And it's not just that one lithography machine. If you're going to print features that are just a few atoms wide, you need to reinvent everything else too. How do you even check your work? You need brand new metrology and inspection tools. How do you find one single flaw buried in a 3D stack of a billion transistors? You need powerful AI just to manage the process. You need totally new materials. Every single piece of the puzzle has to be solved all at once. So after getting slammed by the gold rush, the minefield, and the laws of physics all in one year, where does that leave everyone as we look ahead? That brings us to our final section, the 2026 inflection point. This is the new reality. Equipment makers are in a constant balancing act. They're chasing the massive AI opportunity while always looking over their shoulder for the next political risk. They're funding R&D budgets that would make your eyes water while suddenly facing real state-funded competition. And on top of it all, they're dealing with pressure from governments around the world to build factories in specific places. It's an incredibly complex game now. But you know, that kind of pressure does something interesting. This trial by fire in 2025 forced these companies to get tougher, smarter, and more focused than they have ever been. They had to adapt or get left behind. The pressure didn't break them. It forged them into something new, something ready for this new era of extremes. And so that leaves us with one final crucial thought. The entire future of our connected world, everything from AI to new medicines, it all rests on the machines built by just this handful of companies. After the intense stress test of 2025, the big question we all have to ask is, who is best equipped to actually build tomorrow?